In this video, we're going to look at how to use the product and quotient rules to find the derivatives of a function times a function or a function divided by a function. So let's start with the product rule. Obviously, it's called the product rule because you use it when you have two functions that are being multiplied together, f times g. So to find the derivative of f times g, you take the derivative of f prime of x, times the regular g function, plus f function times the derivative of the g function. And f and g are just names for the functions. So if you look in example 1, find the derivative of y equals x squared times e to the x. So you're just going to let the first function be the f function and the second function be the g function. And if you just set them up, f equals x squared, g equals e to the x, and then underneath you write the derivative of each one separately. So the derivative of x squared is 2x. The derivative of e to the x is just e to the x. So the rule says take f prime and times it by g. F prime times g. So it's sort of a cross multiplication kind of thing. So the derivative of y is going to be 2x times e to the x plus, and then we're going to take the function f times the derivative of g prime. So we would have x squared times e to the x. And then you always want to clean these up if you can, like look for a GCF to pull out. So the GCF in this case would be an x and an e to the x. And so you would be left with 2 plus x inside your parentheses. All right, you try number 2 with the product rule. Again, pause the video when you're done, unpause the video, and the answer will appear. Okay, here's the answer for number 2. If you did not get this, please bring your questions to class. Now we're going to look at the quotient rule. So the quotient rule is used when you have a function divided by a function. And it looks similar to the product rule in the beginning. You start with the f prime of x times the original g function, but the quotient rule is subtraction in the middle. And then you do the f function times the derivative of the g function all over g squared. So the g function squared. So quotient rules, the equation starts as a fraction and the final answer should end as a fraction. Okay, so when you're doing the quotient rule, like in example 1, you want the top function to be f and the bottom function to be g. And you want to do the same setup that you do for the product rule. List out the f function and the g function, and then list the derivatives of the f and the g function. So this would be 10x, and this would be 3x squared. And so you're going to follow almost the same setup. You always start with f prime for quotient rule. So you're going to do f prime times g. So you're going to do 10x, and because g is more than one term, you got to put parentheses around it, x cubed plus 1 minus, and then we do it the opposite way, the f times the g prime. So we have 5x squared times 3x squared all over g squared. You don't have to use brackets on the bottom. You could just use plain old parentheses. It really doesn't matter. Brackets and parentheses are the same thing. And then in quotient rule, we really worry about simplifying the numerator. You do not need to FOIL out the denominator. So 10x times x cubed is 10x to the 4th. 10x times 1 is just 10x minus, and then 5x squared times 3x squared is 15x to the 4th all over x cubed plus 1 squared. And then on the top, we're just going to combine our like terms. So we end up with negative 5x to the 4th plus 10x over x cubed plus 1 squared. Okay, so you try the next one. Again, same idea. Pause the video. When you're done, unpause the video, and the answer will appear. Here's the answer. If you did not get this, please bring your questions to class. Now we're going to look at how you may be asked to use the quotient rule or the product rule given a graph. So in this case, you don't have equations, and a lot of the times you wouldn't be able to figure out the equations, but you can figure out function values from the graph, and you can figure out slope values in this case because it's linear graphs. So the first equation they want us to do is f of x times g of x. So if you're going to find the derivative of this, h prime of x, you want to write out the product rule. So the product rule again is f prime of x times g of x plus f of x times g prime of x. So we're going to refer back to this rule when we're finding the derivative at certain points. So if we want h prime of 1, we want to do f prime of 1, g of 1, plus f of 1, g prime of 1. So f of 1 and g of 1 are just function values off the graph. So you want to read those off the graph. So f of 1, I come to the f graph, f of 1 is 2. So I'm going to replace f of 1 with 2. And then g of 1, if I come to the g graph, that's this straight line here, at 1, the y value is 3. So g of 1 is simply 3. Now, to get the primes, the derivatives, I have to use slope. Remember, derivative is slope of the tangent line. So if I come to f prime at 1, I really want the slope at 1. And this is just a nice straight line. You can see that this line has a slope of 4 up. It goes up 4 and over 2 to get from point to point. So that's a slope of 2. So f prime is equal to 2 here. So I'm going to replace f prime of 1 with 2. And I'm going to do the same thing on the g graph. I want g prime of 1. Well, g prime of 1, g goes down 4 and over 4. So g prime is just a slope of negative 1. So I'm going to replace g prime with negative 1. And then it's just a simple arithmetic. 2 times 3 is 6. 2 times negative 1 is negative 2. So h prime of 1 is 4. Okay, we'll do the same thing with h prime of 2. We're just going to plug in 2 everywhere we see x into our product rule formula. And so the first thing you probably want to do is just go ahead and read off those function values. So the function values at 2, so f of 2 is 4, all the way up here at the top. So f of 2 is 4. And g of 2 is 2. And then we need to read off the slopes. So f prime at 2, if you notice up here, there is a sharp corner at 2. If you remember back from when we talked about differentiability last chapter, sharp corners, the derivative does not exist. So f prime of 2 does not exist. So we're going to plug in d and e right here for f prime of 2. And then g prime of 2, well, that's also a slope of negative 1. So we're going to plug in a negative 1. Well, what does all this really equal? Does not exist times 2 is still does not exist, and does not exist plus negative 4 is still does not exist. So because one of the derivatives does not exist, the f prime derivative, that makes the h prime of 2 derivative not exist as well. Okay, so pause the video here. I want you to try h prime of 3. When you're done, unpause the video and the answer will appear. Okay, so you should have gotten that h prime of 3 is equal to negative 4. Okay, in the next example, we're going to do a quotient rule. Now they've given us a function k of x, and they want us to find f over g. So we want to find the derivative of k at 1, 2, and 3, just like in the previous example. So we're going to write out the quotient rule. K prime of x is equal to f prime of x, g of x, minus f of x, g prime of x, all over g squared. So for a, we're going to plug in a 1 everywhere we see x. So f prime of 1, g of 1, minus f of 1, g prime of 1, all over g of 1 squared. Now, a lot of these values we already read off when we did the product rule. If you remember, f of 1 was 2, so we're going to plug in a 2 for f of 1. G of 1 was 3, so we're going to plug in a 3 for g of 1. And then the derivatives, again, the derivative of f at 1 was 2, so f prime was 2 here. And the derivative here at g prime of 1 was negative 1. So f prime was 2, and g was negative 1. And then it's just a matter, again, of doing arithmetic to clean it up. So on the top, we have 6 plus 2 over 9, which gives us 8 over 9. Okay, so for part B, we're going to set up the same thing. K prime of 2 is equal to f prime of 2, g of 2, minus f of 2, g prime of 2, all over g squared. Now, if you remember, f prime of 2, again, that's that sharp corner, f prime of 2 does not exist. If you take does not exist times anything, it still does not exist. So because f prime of 2 does not exist, you can automatically say the answer is D and E. The derivative does not exist for k prime of 2. Okay, so we'll do C together for this one. So again, plug in k prime of 3 is equal to f prime of 3, g of 3, minus f of 3, g prime of 3, all over g of 3 squared. Sorry, I'm running out of room here. Okay, so same idea. Find f of 3 and g of 3. So f of 3 is f of 3 is 2, g of 3 is 1. So I have g of 3 is 1, f of 3 is 2, and then so f of 3 was 2. G of 3 was 1, so on the bottom I just have 1 squared. And then I'm going to find my slopes. So the slope of g is always negative 1. It doesn't matter where you are. So g prime is negative 1. And on this side of the equation, the slope of f, you're going down 4 and over 2. So the slope of f is negative 2 here. So I'm going to plug in a negative 2. So I get negative 2 plus 2 over 1. So I just get 0, and 0 is fine. That's a perfectly acceptable answer. So the last example, we're actually going to let you try all 3 of these on your own. Again, pause the video. When you're done, unpause the video, and the answers will appear. So for A, you should have gotten negative 2. For B, you should have gotten D and E. And for C, you should have gotten 0. If you have questions, please bring them to class.